So the process is going to be very similar to what we had looked at when we were doing completing the square in chapter 1, which was basically working with circles when we had to find the center and the radius. Actually, the example that you were kind of talking about, if you had to find your point through a line, your circle passing through a point and a line, you can do it then. Or the examples we had specifically looked at was when our circle equations were given in the form of x squared plus 8x, and they didn't have the whole factored form in there. So the idea is if we wanted to try and factor our expression, completing the square will definitely work. Now, completing the square, the beauty about this method is it can work on any quadratic equation. It does not have to be as restricted as your factoring and square root property is. So this will work with any type of quadratic equation, and you will still be able to solve it. So let's look at our first example here. Okay. So you've got m squared minus 12m plus 33. Does anybody remember doing completing the square in chapter 1? Chapter 1, who cares? It's been so long. A little bit. I mean, not chapter 1, but section 1.3, I think. Okay, let's see if you guys remember or not. So we've got m squared minus 12m plus 33. So remember, for completing the square, you're only working with the leading coefficient term, the leading term and the middle term. So we actually don't need the 33. So the first thing you're going to do is move that 33 to the other side. Okay, so let's start by subtracting 33 on both sides. This guy cancels out. You're left behind with m squared minus 12m equals negative 33. Okay. For the process of actually completing the square, you need the coefficient of your middle term, which will be that 12m. Now, since we have to actually use the square process for completing the square, you don't have to worry about that negative sign on the 12. So remember, for completing the square, the process is we take the coefficient of our middle term, which is the b term, take its half, and then we take a square on that value. We had talked about that, remember? So your middle term, of course, is coming from the m term, which is the 12. 12 divided by 2. What is 12 divided by 2? 6, very good. And then 6 squared would be 36. So you are going to take 36. And to maintain the balance of our equation, we're going to add it to both sides of our equation. Do you have the 12 1.5 handout? No? Okay. Okay, so go ahead and add 36 to both sides. Okay. So we have m squared minus 12m plus 36, and then negative 33 plus 36. What do we get on the right-hand side? 3, very good. The left-hand side is now what we call as a perfect square trinomial. So again, to refresh your memory, perfect square trinomial means it's going to factor into the same terms, right? So think of two numbers that multiply to give us 36 and add up to give us negative 12. 6 and 6 basically, right? Think about it again. Remember, we had done this. Two numbers that multiply to give us positive 36, add up to give us negative 12, which means both numbers would have to be negative 6 and negative 6, right? Negative times negative gives you positive. So 6 times 6, 36. Negative 6 plus negative 6 is negative 12. So this guy will factor into m minus 6 and m minus 6. Or we actually prefer to write it as m minus 6 squared equals 3. Another trick that might help you is when you look at that perfect square trinomial, which is the m squared minus 12m plus 36. Whenever your middle term is negative and constant term is positive, both our factors have to be negative numbers. So we know it had to come out to be negative 6 and negative 6. And then, of course, you can do that little cross at the bottom and still get that. So completing the square is this, what we just did. We moved the 33 to the other side. We took our middle coefficient, which was 12, took its half, which was 6, and then square of 6 is 36. We take that 36 and add it to both sides of our equation. Clean up the right-hand side, factor the left-hand side. Once you get to this stage, what does this look like? Not you. Doesn't this look like these problems that we did last time for square root property? So that's what we're actually doing, is we're using the completing the square method to convert our equation to look like the square root property format. And then we can use the square root property to help us get the answer. So again, let's take a look at that. So now I have m minus 6 equals 3. So by the square root property, so we take a square root on both sides. Remember, whenever you take a square root, you get one positive, one negative root. And then on the left-hand side, the square root and the square cancel each other out, leaving us behind with just m minus 6 equals plus or minus square root of 3. So what's the last thing we need to do here? Very good. Move that 6 to the other side. Yeah. So we should have positive 6 plus or minus square root of 3. And that plus or minus is where we're getting our two answers coming from. So your solution set is going to be 6 minus square root of 3 and 6 plus square root of 3. So one's with the minus sign, one's with the plus sign. Questions on, well, whatever number this one was, 6. And again, keep in mind, we don't do decimal approximations for our answers. We leave them as exact. So you don't need to put this into a calculator and find out what those approximate values are. My math lab will want exact answers, and same thing for exams. So again, remember, we're using completing the square to convert it into the form so that I can use square root property to solve them. So it's just basically coming up with a better way of writing down our equation, because the way they were given to us, factoring would not have worked, because think about it. What two numbers would multiply to give us 33? 1 and 33, or 11 and 33, right? And 11 and 33 or 1 and 33 do not add up to give you negative 12 in any combination. So it wouldn't have worked. So we know factoring wouldn't have worked. So the other option was converting it and using the square root property. Now that's the same exact process we're going to try and do on number 7. So you can see that 2 is already on the other side. So we'll leave him just there. You've got 3x squared plus x equals 2. Okay, so this one is a little bit of a different problem than what we did in number 6. And the main thing here is you have 3 on that x squared term, right? In the previous example, we didn't have anything on our m squared term. So that's the big difference here is we have this 3 leading coefficient on the x squared, whereas in number 6, you only had m squared. So when you are using the square root property, it only works if your leading coefficient of x squared did not have that 3 on it. So our first step here, before we can even use the process of completing the square, is to clean up our expression, which means divide the entire equation by 3. Okay, you cannot have your leading coefficient of 3 on that. So I'm going to take each term and divide it by 3. Whatever that leading coefficient is. So whatever this number will be here on your square term, that same number. So if it's a -5, divide everything by -5. So 3 specific to this example, but not for every. Yeah? Like as an exception? No, for completing the square, it's always the same. Make sure your x squared term has 1 as a leading coefficient and nothing else. So even let's say that was a negative x squared, we would have divided the entire equation by -1. So it has to be +1 as your leading coefficient. So once we cancel that 3 out, you should be now left behind with x squared plus 1/3 x equals 2/3. So this is going to be the interesting part now. We've gotten rid of that 3, but now my middle coefficient has become a fraction, right? 1/3. So when I try to use my completing the square, which is taking the middle coefficient, dividing it by 2, and taking a square, dividing by 2 is the same thing if I took my b, which is my middle term, and multiplied it by 1/2. So I'm actually going to use that idea instead of dividing it by 2. I'm going to think of that being, because my b is a fraction now, right? So it's going to be easier for us to think of dividing by 2 as multiplying by 1/2, because if we took 12 in our last example and divided by 2, we got 6. What is half of 12? Same thing, right? So that's what's happening here. Just multiply by 1/2. So for us, we're going to take 1/3 and multiply by 1/2 and then square our answer. So what is 1/3 multiplied by 1/2? Very good. 1/6. And a square of that, 1/36. Very good. So this is what we're going to need to add to both sides of our equation is 1/36. So you've got x squared plus 1/3 x plus 1/36 on the left. Then on the right-hand side, 2/3 plus 1/36. Let's clean up the right-hand side first, and then I'll show you a shortcut method for factoring the left-hand side. So what will we need to do to add 2/3 with 1/36? Common denominator, very good. So can I use 36 as my common denominator? 3 times what will give us 36? Very good. So let's use 36 as our common denominator, which means we'll multiply the fraction of 2/3 by 12, both numerator and denominator. Is that color too light? Okay, 12 times 2, 24. 12 times 3, of course, is 36. Plus 1/36 will give us. Very good, 25/36. So your right-hand side will now become 25/36. So there we are back again, right? Adding fractions. So those things, of course, will keep popping up with different denominators. Now, here's the thing. We added the right, and of course, your calculators can do most of that calculation also if you are a little unsure about that. But it's always good to know how to add fractions with different denominators, which is what we have been doing so far in our lab. Now about factoring this left-hand side. So it can actually be a lot easier than trying to reinvent and do this from the beginning. It actually always comes out to be this term right before we took a square on that. So let's go to our previous example or previous page and look at this guy here. We had taken 6 squared to make a 36, right? And our trinomial factored into 6 times 6 and minus 6 squared. So that's actually the same thing that's going to happen in this example. Since we took 1 over 6 to make 1 over 36, that's what our left-hand side is going to factor into. So this will actually factor. And since both my signs are positive for the middle term and positive for the constant term, we're going to have a positive in our factoring. So this will now be x plus 1 over 6 and x plus 1 over 6 as my two factors. Now, of course, I know when I multiply 1 over 6 with 1 over 6, that's 1 times 1, which is 1. 6 times 6, which is 36, it gives me this fraction. But when I add these two, will I get 1/3? So when I add 1/6 and 1/6, will I get 1/3? Yeah, you should. Otherwise, our factoring does not work. They have the same denominator, 6. 1 plus 1 is 2. 2 over 6 reduces down to 1/3. So you can always check your math. So we know this factoring works. And then now put it into a single parentheses. X plus 1 over 6 to the second power equals 25 over 36. Factor the left-hand side, add the right-hand side, and of course, we're ready to use our square root property at this point. Remember, that is where we take a square root on both sides of our equation. And with the square root comes a positive and a negative sign. On the left-hand side, your square root and square will cancel each other out, leaving us behind with just x plus 1 over 6. What happens on the right-hand side? Yeah, square root of 25 is 5, right? Because it's 5 times 5. And square root of 36 is 6. So you'll end up getting positive and negative 5 over 6 on the right-hand side. So do we know what our x values will come out to be? Subtract the 1/6 from both sides. Oh. Okay, so you should have x equals negative 1/6 plus or minus 5/6, and of course clean those up. So one's with the positive 5/6, one's with the negative 5/6, and you can clean this up. You don't have to leave it like that. So what will our final answers look like? Sorry? And the other one? Because you're doing -1 and -5. So what does that come out to be? -1, -5. Yeah, you're going to end up with -6 over 6 from the left-hand side, which will, of course, become -1, right? On the other side with the negative 1, 6, positive 5, 6, negative 1 plus 5 is, Levi, what did you say? Yeah, it's going to be 4. Negative 1 plus 5 is going to come out to be 4 over 6, which will reduce down to 2/3. So you're going to get nice, clean, real number answers here. So your solution set will come out to be negative 1, positive 2/3. Questions on this example? So like I said, this example was a little bit different, and the main reason for that was because of that leading coefficient of 3 on our x squared term. So for completing the square to work, our leading coefficient can be nothing other than positive 1. So that's why we first started by dividing the entire equation by 3, which meant our middle term ended up becoming 1/3, right? So when you are completing the square, instead of dividing by 2 with fractions, think about multiplying 1/2. So we're doing 1/3 times 1/2, which gave you 1/6. 1/6 squared gave us 1 over 36. So we're adding that 1 over 36 again to both sides of our equation to maintain that balance. And then add the right-hand side, factor the left-hand side. And as I was telling you, it's always going to be this number right before we square it that will help us with our factor. So that 1/6 is what our factors will have. And then of course, since this is to the second power, use the square root property, clean up your answer. And in this case, we ended up getting -1 and positive 2. Did you have a question? Say that one more time. Oh, that was right here when we added the 2/3 with the 136, right?
You just make the 3 to 36.
Yeah, yeah. Okay, very good. Anybody else have a question on this part of the example? Okay. So this was our completing the square. Now, you guys might be familiar with this last one, which is the quadratic formula. So just like completing the square, a quadratic formula will work on any quadratic equation. It has no restrictions. So completing the square and the quadratic formula work on all types of quadratic equations. The restrictions are with your factoring method and the square root property method. But before we get into the quadratic formula, I do want to kind of summarize our completing the square. You always take your constant term, which is the term without any variable, right? Take your constant term, always get it out of the way. So move it to the right-hand side. We're always making sure that our leading term is going to be just 1. If it's not 1, divide everything by that number. So whatever that number might be, positive, negative, divide by that number. Then you take the middle term coefficient, which is what we call as the B term. Take that coefficient, take its half, square it, add that number to both sides, and then of course factor the left-hand side, clean up your right-hand side, and then you do have to use the square root property to get your final answer, okay? Again, guys, you will need to remember the quadratic formula. It will not be given to you on the exam. So the way our A, B, and C terms work, the standard form of the quadratic equation is A, which is the leading coefficient of the x squared term, plus bx, b is the coefficient of the middle term, and c is the constant term, and we always get 0 on the other side. So if your quadratic equation is not given with 0 on the right-hand side, make sure you move everything to the left, clean it up, and then start putting it into your quadratic formula. So you're starting with negative b, which is coming from the middle term, plus or minus. Because of that square root, you're always going to have plus or minus. Inside the radical is b squared minus 4 times a and c, which is coming from your equation. And then the entire thing is divided by 2a. Okay, so you will need to remember the quadratic formula here. And then let's see, this one is given to us in the standard form. You've got 16x squared minus 24x plus 9. So what was that? 16x squared minus 24x plus 9 equals 0. So the first thing I actually like to do is just write down what my A, B, and C values are. So A comes from the leading term, which will be 16. B from the middle term, take the sign with the number. So since it says negative 24x, your B term is going to be negative 24. And then C is positive 9. Okay. Now, let's write down our quadratic formula. You guys don't have to since it's on the same page for you, but it's negative B plus or minus square root of B squared minus 4AC over 2A. But I will recommend when you guys are doing homework, write it down for every problem so it helps you remember what the formula is. Okay, so this is the part you got to be careful about. Our formula is starting out with negative B, and the B number itself is also negative, right? Negative 24. Yeah, so you do end up with two negative signs. So there's the negative from the formula itself, and then since B has a negative on it, you will end up with these two negative signs here. And of course, two negatives become positive. And I'll do that in the next step. Plus or minus, then inside my radical, I've again got B squared, which will be negative 24 in parentheses, and the square outside. If you are in the habit of not writing the negative number in parentheses, then it's a good chance you will carry forward that negative sign, kind of like what you were showing me. So if you put it in parentheses, then you remember that, hey, I have to multiply the negative with the negative, which makes it into a positive. So just a little thing, but it can actually help you avoid that confusion, right? And then we've got minus 4 times A. Our example, A is 16, C is 9. And then remember the whole thing is divided by 2 times A, which is 2 times 16 for us. And you know, once you get comfortable, you may not have to write each step down, but I like to show you so you know where you need to be careful about. So I've got those two negative signs in the front with the 24. So those two negatives will end up becoming positive, and you get positive 24 plus or minus. Oh, right here, the negative B and the negative from the 24. I think you already put it as positive, didn't you? Yeah, you've already got it as positive, so you're fine. What is negative 24 squared, or just do 24 squared? 576. All righty. And can somebody tell me what is 4 times 16 times 9? Same number? Really? Okay. That'll make our life easier. Okay, so 4 times 16 times 9. And we are trusting Iram on that math. Okay, good. Okay, denominator 2 times 16? 32. Okay. So of course, you know, think about, please excuse my dear Aunt Sally, we always try to do parentheses of the groupings. First, so you can think of the numbers inside the square root as your grouping. So let's go ahead and clean that up. What do you end up getting inside the square root? 0. 576 minus 576. So you've got 24 plus or minus square root of 0. Square root of 0 is 0. Again, guys, you don't have to write each step down. I'm just showing you what happens as you progress. So the square root of 0 will become 0, which means you're really adding or subtracting nothing. You end up getting only 24 over 32 in this case. So what happens was, since after the plus or minus sign we had 0, you're not going to end up with two different answers here. Because if I add 0, it's still going to be 24. If I subtract 0, it's still going to be 24. So this is one of those examples where instead of 2, you only get one value for your x. And what is 24 over 32 when you reduce it down? 3/4. Because 8 is common between both of those, right? 8 goes into 24 3 times. 8 goes into 32 4 times. So your solution set will have only one number, which is 3. Yeah, very good.
I'm not very good at making this really thing.
That's fine. My math lab gives it
It
to
looks
you.
like
You can make it look like a snake. It doesn't matter. They don't have to be perfect. Question on this example. So again, we started out by identifying our A, B, and C values. Remember, you take the sign with the number. So since our 24 was negative, your B value becomes negative 24. Now, since your formula has negative B, that's the negative from the formula, and then B itself is bringing a negative sign. Two negatives make a positive, so that's where the positive 24 is coming from. And take your negative 24 squared, so that's negative times negative again becomes positive. 24 squared is 576. 14 times 6 times 9 also gave us 576. So basically subtracting the same number, we ended up getting 0 inside our radical. So since you're adding or subtracting 0, you only ended up getting one answer, 24 over 32, and then reduce your fraction. Okay.
So because 9 has a
9.
number on the right side of the equal sign, you subtract the 9x squared.
Yeah, you have to bring all your terms on the same side. So you can subtract the 9x squared. If you don't want to make 9x squared negative, you can move the other two terms. But I like moving 9x squared because you're just moving one term, right? Instead of moving two. But if you are very picky about not having that leading term being negative, you can do it accordingly. But you know, that's the beauty of the quadratic formula. It actually works itself out, so it doesn't matter. So let's start by moving the 9x squared to the left-hand side. So that's 12x minus 5, 9x squared. We're starting out by subtracting 9x squared. If anybody is doing it the other way, you can try by moving the 12x and the 5 and see what happens. But you should always have all the terms on one side and 0 on the other. Doesn't matter which numbers you are moving. So now I have 9x squared plus 12x minus 5 equals 0. If you don't bring your terms on the same side, quadratic formula is not going to work. Okay, so let's identify our values. I'm actually going to put them on the side here. A is what? Very good. Negative 9. B, positive 12. Good. C, yeah, negative 5. And again, I'm going to write down my formula. X equals negative b plus or minus square root of b squared minus 4ac over 2a. Okay, if you get in that habit, like I said, it helps you remember your formula. So let's say this time our b is positive, right? It's a positive 12. So you're going to have that negative from the formula, and b itself is just 12. So just one negative sign. Plus or minus square root. And then you've got b squared, which in this case will be positive 12 squared, minus 4 times a, which is negative 9, c, which is negative 5, oops, and then the entire thing divided by 2 times a, and again your a is negative 9. So when you clean this up, what do you get? Negative 12 will stay the same, right? Because there are no other signs to clean it up. Plus or minus. What's 12 squared? Very good, 144. Now this second part, you got to be careful. You've got three negative signs. You've got the negative from the formula, so that's the -4, the -9, and the -5. So two signs, negative times negative will become positive, but then I've got one more negative sign, so you should have a negative left behind. If it helps, when you're multiplying, just multiply with the sign. So you can do -4 times -9 times -5, and you'll automatically get a negative sign left behind. So what is that number? -180, yeah. And my denominator? Very good, -18. So you will have a negative sign show up on the denominator this time. Okay, everybody okay so far? Putting the numbers in the formula and cleaning it up a bit. Okay. Inside the square root, what is 144 minus 180? -36, yeah. No, you will have a solution. It will be what? Yeah. So you will definitely get an answer. It's just going to be imaginary number in this case. Everybody okay up until this point? All right, let's look at that -36 inside our radical. So do you remember how we defined the imaginary number last time? Very good. I is defined as square root of -1. Remember, were you here?
I was not here.
Yeah, I think we talked about this last class. So what happens is we define the imaginary number I as square root of -1. So what happens is you can take that square root of -36 and write it as -1 and +36. So the -1 can now be defined as I, and you can make that 36 into a positive number if you use that definition. So that this part here will become I. Bring him outside, and now you have a positive square root of 36, and you can simplify that. So square root of 36, 6. So this guy will become 6i. So now you will have -12 plus or minus your square root of -36 will now become 6i. And then my denominator is still -18. Okay. What do you see common between 12, 6, and 18? 3 and, right? Go with the largest number that is common. So that's actually going to be 6. So on my numerator, I'm actually going to bring outside a -6. Why am I bringing a -6 outside? Because I've got a negative sign here, right? So I can bring the negative, and I know plus or minus also has a negative sign in there. So I can actually bring outside a -6. So -6 will go into -12 how many times? 2? Okay. Trying to think how I want to say this. Okay, so think about the plus or minus 6i at the end that I have here. If I take a negative sign out, what happens to plus 6i? It will become -6i. If I take a negative from a -6i, it becomes a +6i. So you're still going to get one positive and one -6i. They just change places, right? But it doesn't matter because I can still write it as positive and -6i. So honestly, bringing that negative sign out here helps us make this first number into a positive, but the plus or minus 6i will still end up staying plus or minus 6i. So that will not change. It's just whichever was the positive has now become negative, and which one was the negative has now become positive, but I still have both of them in there. And then I still have my negative 18 on the bottom. If I want to reduce that negative 6 with negative 18, negative 6 goes into itself once. Negative 6 goes into negative 18. Yeah, 3 times. So you are going to end up with a negative 6 has been canceled out. I'm left with 2 plus or minus 6i on the top and a 3 on the bottom. So it's literally about cleaning up our fraction. You were at negative 12 plus or minus 6i over negative 18. Either identify that 6 goes into all of them, and then you could have actually taken, oh, I don't think I, so you could have taken 6 and reduced everything by 6. So 12 divided by 6 would give us 2, and you would actually still have that negative 2 there. 6 goes into itself 1 time, so you would basically just have I left behind there, right? And then 6 would go into 18 3 times, so that would still be negative 3. And then you would have ended up with basically negative 2 plus or minus I over negative 3. And then you would still need to reduce those negative signs, right? Cancel them out, giving you positive 2 plus or minus I over 3. And I just realized what I did there. I'm taking the negative 6 out, which means I shouldn't have this 6 here. And I shouldn't have that 6 there because I'm taking it outside. So you can do it by canceling everything out by 6, or you can do it the way I did it, which was factoring out that 6. Now, once you get down to this, you can split this up into your solution set. One's with the positive, one's with the negative. So that will be 2 minus I over 3, 2 plus I over 3. Okay, look through the math and see if you have any questions for me. This is just to show you a different calculation. Then on the next page, they're just summarizing the steps. And in this case, they're basically saying if you don't even have a middle term, you don't have a x term, you just have ax squared plus c, you can actually directly apply the square root property, which would technically mean take the c to the other side, divide everything by a, get your x squared by itself, and then use the square root property. If factoring can work, obviously you want to try factoring. I think factoring is probably an easier method compared to the other ones because it doesn't take that long. However, if you're uncomfortable with factoring, then obviously it may take you just a little bit longer. They're saying if the factoring and the square root property doesn't work, you can use quadratic formula. For that matter, you can use the completing the square formula. And that's what they're talking about here. And then of course, when it comes to graphing, they are talking about finding your x-intercepts where you would basically be solving this equation for x, which is what we have done right now. So all these answers that we came up with for these equations basically gave you the x-intercepts for these functions when we start graphing them. And of course, when you're finding the y-intercept, remember you make your x values 0. So all of those processes still stay the same.
Then you can use the quadratic for pretty much any of those problems.
Any quadratic equation, yeah. If b is 0, you just put 0 where your quadratic formula has a b in it. But yeah, it would work for all quadratic equations. Okay. Now, so you can see how we came up with different answers. One of them had only one answer, right? That was the one we ended up with 3/4. We had imaginary solution as some of our answers. And then when we did, what was it, example 6 and 7, we had real number answers in that. So how do we know, are we going to get 2 real numbers as our answer? Are we going to get 2 imaginary numbers as our answer? Or are we going to get one single answer like we did with that 3/4? So that actually comes from what we call as the discriminant. And the discriminant is this value, b squared minus 4ac, which is basically part of our quadratic formula right underneath the radical sign, the square root sign. So b squared minus 4ac is actually what helps you decide if you're going to get 2 real numbers, 2 imaginary numbers, or 1 real number. So the idea is if inside the radical, this value comes out to be positive, you are going to get 2 real numbers. If inside the radical, this value comes out to be negative, which is what happened in this example, right? You had negative 36 inside the square root. That's why we got 2 imaginary. If this is positive value here, you get 2 real numbers. And
So if it's negative, there's no real solution.
no real solutions, yeah. And if your value underneath the square root comes out to be 0, that's when you get 1 real solution. So it's actually that value of b squared minus 4ac that determines or decides what kind of solutions you are going to get. So you can see this little table here. If the value inside the square root is positive, you will have 2 real solutions. If the value inside the square root is 0, you get 1 real solution. Now for negative, they are saying you have 0 real solutions, but technically this should be 2 imaginary solutions here. So if you want, you can just say 2 imaginary solutions. So we know they're not real numbers, but they are going to be imaginary numbers. So this next set is not asking us to solve the equation. They don't want the answer to the equation. They're just saying, what is the value of the discriminant going to be? And based on that, what will our number of solutions be? What will the solution end up looking like? So all you are doing is doing the b squared minus 4ac part. That's it. Okay, so 9x squared minus 30x plus 25. Minus 30x plus 25. So just the discriminant. Which is b squared minus 4ac. You're not doing the entire equation. So b squared minus 4ac. What's our b term? Negative 30. So that will be negative 30 squared minus 4 times a is 9. C is 25. What is negative 30 squared? Yeah, this 3 times 3 is 9, and then put 2 zeros on that. Minus 4 times 9 times 25. 900. So this means your discriminant value is coming out to be 0. So remember what that means. In our quadratic equation, I guess I'm going to do that down here.
No, because it's 0, so you'd have 1.
You would have one real number because that's the negative b plus or minus b squared minus 4ac over 2a. So we are saying this part here is coming out to be 0, right? Which means you will have one real solution, and that will actually end up being this portion just here, negative b over 2a.
And that is your solution, negative b over 2a.
Yeah, so whatever those numbers come out to be, which is what, negative 30 over 2 times 9. Because remember, if this part is coming out to be 0, this whole thing,
Right.
that means you're only going to be left behind with this part.
Right.
So yeah, that comes out to be your single solution. Not too bad, huh? Once you figure out what that discriminant is.
Yeah.
Question on this guy? Number 10? We should. And I'm telling you, if you do that, that whole portion is already taken care of, and then you're just cleaning up your fraction. So yeah, I definitely recommend.
You can do that. You can just figure the discriminant out and then plug in the rest.
Yeah, plug in the rest. Very good. Yeah, exactly. Works out really well. So this was number 10.
So our answer for that, all they're wanting is the one real solution.
One real solution, yeah. So they just want to know how many real solutions you will have. And the value of the discriminant was, of course, 0. Okay, so how about you guys take 11 and 12, put it into that b squared minus 4ac, and let's see how many real solutions we'll have. So this guy is 5x squared minus 6x plus 2. What are you looking at? For 11? Okay, so let's see. Why are you getting negative 76? This negative 6 squared, negative and negative will become positive. So that's positive 36, right? And then negative, and then you only have one negative sign, so that negative will stay. 4 times 5 is 20. 20 times 2 is 40, right? So you're getting a negative answer.
So in that case, you have 2 imaginary solutions.
Very nice. Yes, you will have 2 imaginary solutions because you ended up getting a negative 4. So did you keep the negative sign on your 36? Is that what happened? Okay, yeah, so be careful with that. So since we ended up getting negative 4 as the value of the discriminant, you will have 2 imaginary solutions once you solve the quadratic formula. Okay, and we've got one more example. Sure. Did you put your negative 6 in parentheses? Yeah, so what it's doing is it's keeping the negative and only doing 6 times 6. So if you wanted to do negative 6, put your negative 6 in parentheses and then square on the outside. Okay? Does anybody know what 12 will be? Two real solutions. Okay, let's verify that. So you've got 7x squared plus 12x minus 1. So again, here our A value is 7, B is 12, and C is negative 1. So just a discriminant. And this comes out to be 12 squared minus 4 times 7 times negative 1, right? 12 squared. Okay. Now be careful on that second part because you've got the negative 4, but then you also have the negative 1, right? And you're multiplying all these numbers. So negative times negative will actually give you a positive in the middle. And what is 4 times 7 times 1? 28. 144 plus 28? 172. And that's a positive 172, right? So how many solutions? 2, but which kind? Yeah, you will have 2 real solutions. Now, there's one thing I want you guys to be careful about. I kind of hate that my math lab does this. If they don't give you the option of 2 imaginary solutions, and I actually don't remember if it gives you or not, but if you don't see the 2 imaginary solutions for this guy, you can also have 0 real solutions, because if it's not real, then technically you don't have real number answers, right? You have imaginary answers. Then you don't have, in the real number set, you don't have a solution. So I'm not sure, I can't remember if my math lab does to imagine. If it does, you're good to go. But if you don't see that option, then you're doing 0 real. Okay? And then number 12, of course, we got a positive for our discriminant, so we know we'll get nice clean 2 real numbers.
You generate our tests from my math lab, right?
I do.
So on our tests, would you want us to solve for the 2 imaginary solutions? Or would you want us to leave it as 0 real solutions if
for
the
this,
math lab does not do imaginary solutions?
Yeah, so for this one, I actually cannot remember if it's just multiple choice for this one. Okay. Is it multiple choice? It is. So yeah, you would just be selecting the option. But if it's one of these examples where they're actually asking you to solve, then you would actually solve for the imaginary numbers. But if it's just this discriminant question, then you can leave as 0 real numbers, if that's the option they give you. Okay. Yeah, but when it comes to actually solving the equation, you do want to solve for the imaginary numbers. Gotcha. So as soon as you hit negative inside your radical, just don't say, oh, it's 0 real. Solve it. Does that help? Yeah, wonderful. Any other questions about basically solving the quadratic equation and using the discriminant to see what kind of answers we have? So remember, there's 4 methods: factoring, square root property, completing the square, and the quadratic formula. So your exam questions for this section will tell you the specific method you have to use. If you do not use the method that the problem asked you for on the exam, you will not get full credit for the problem. So if they specifically told you to use completing the square and you use the quadratic formula, you will not get credit for that. Because the idea is we want you to be comfortable using the different methods for solving your quadratic equation. If it says solve by using the method of your choice, then obviously that leaves it wide open. Use whichever method you find convenient. But if it says solve using square root property, then make sure you're using square root property. If it says solve by factoring, make sure you solve by factoring. So follow the instructions and be careful about that. Questions on any of this? Okay, so the last part here, we're getting into applications. How can we use quadratic equations to help us solve application problems? So here, as you can see, we're talking about Imogene wants to make an open top box for packing baked goods by cutting equal squares from each corner. So she's cutting out these squares from each corner. And she has an 18 by 14 inch piece of cardboard. For versatility, she wants the bottom of her box, I guess, to be 80 square inches. So we want to know what should be the dimension of the square that we're cutting from each of the corner, and they'll be all the same size, because the idea is the bottom of her box should be 80 square inches. So we need to know what these corner measurements have to be that she can cut it out. And we know the total length and width of the cardboard is 18 inches by 14 inches.
The area of that rectangle is the 80.
The bottom base,
Yeah.
Not the entire thing, but yeah, the base, 80. Okay, so this base here has to be 80 square inches. This is the X by X box or corners that she wants to cut out. That's one of the options. So how can we go about setting this up so we can get a quadratic formula to help us solve this?
Use the ratio of the 14 by 11 to see like how like far apart they are. Right?
So-
Like 8 and 10, 14 to 11. Every.
Okay,
That's all.
but we don't know if that's certainly it, right? Because there are other combinations to still get 80 as our answer. Did you have your hand up, Patrice? No? Okay, so the idea is we know originally the box is 11 by 14, and this is using the idea of area of a rectangle, right? Because your cardboard shape is a rectangle. So we know the area is length times width. Now the idea is we know that the total bottom area of our cardboard has to come out to be 80. So the idea is what should this length or width, however you want to look at it, what should the measurement of that side be? And what should the measurement of this side be, so that when you multiply them, you do in fact end up getting 80 square inches as your area. So if the total width of our cardboard is 11 inches, what do you think the measurement for this side should be if we know this distance is X and this distance is X?
Less than that. Should be less than 11.
Yeah, it will be less than 11 by how much? Yeah, because think about it, the whole thing is 11. If I remove this X side from here and I remove this X side from here, will that not give me the width of that base for 80 inches? So the width of her box rectangle will actually be the 11, which was the original width, minus those two X's, which form part of that corner. In that same way, if my full length here is 14, what will this length for the base be? Very nice, same exact calculation. It's going to be 14 minus the 2x. That's actually your equation right there. I know it doesn't look like much. It will. So this is our length times width, which equals the area of the base, which is 80 square inches. So your magic keyword for the left-hand side, oil. Gotta multiply that out. So let's start with the first. What is 11 times 14? I will trust you on that. 154, very good. Now the outer for both, so that will be 11 times negative 2x. Very nice, minus 22x. Inner, which would be the negative 2x multiplied with the 14. Negative 28x. And the last terms would be negative 2x with negative 2x. Very good, positive 4x squared. Okay. While you guys are cleaning that up, let me just review it a little bit. So we took our original sides of 11 and 14. We know we have to remove these square corners, so they're going to be x by x, right? Since it's a square, length and width will be the same measurement. So from the 11 inches, we're subtracting x and x, so that's subtracting 2x. From the longer side, the length, it's total of 14 inches. And same thing, we're removing these two x's, so that's 14 minus 2x. And we know length times width has to multiply to 80 square inches. Then we FOIL our two parentheses, so 11 times 14, 154. 11 times negative 2x is negative 22x. Negative 2x times 14 is negative 28. And then negative 2x times negative 2x is positive 4x squared, and of course that equals 18. Combine your two middle terms, so what's negative 2x and negative 22x and negative 28x? So we've got 154 negative 50x plus 4x squared.
And you subtract the 80.
Very nice. Yeah, we still got to get that 0 on one side. So go ahead and subtract 80. And what is the 80 being subtracted from?
The 154.
Very nice. So minus 80 on that side.
74 minus 22x plus 4x.
Hold on. 74. What did you say after that?
Minus 22x.
Shouldn't you still have negative 50 there?
Oh, yeah, sorry.
Right? All right, be careful. You don't need that.
Minus 50x plus 4x.
Very good. Now, I'm a little OCD when it comes to my equations. I don't like it in this reverse order, so I'm actually going to rewrite it as 4x squared minus 50x plus 74. Put it in standard form because my brain doesn't work otherwise. So you've got your quadratic equation now. And we need to find that x measurement because we still need to know what that measurement of the square is going to be. So out of the methods that we just talked about for solving a quadratic equation, which method would you use? And this one is open to you. It's your choice.
I kind of like the.
So do we just solve it on our own? Yeah, whichever method you want to use. The formula?
Yeah, I like quadratic.
The quadratic formula? Yeah, and you can definitely use that. So identify your A, B, C values, put it into the quadratic formula, and let me see what answers you guys come up with. Sorry? Yeah, sure. So A is 4. What's B? Negative 50. C? Very good. And then your quadratic formula is x equals negative b plus or minus b squared minus 4ac over 2. All right, so let's see. If we plug our numbers in, we have negative b. B itself is negative 50 plus or minus b squared inside the square root would be negative 50 squared minus 4 times a, which is 4, c, which is 74, and everything divided by 2a, which is 2 times 4, right? Okay, so the two negative signs in the front will end up becoming positive here, giving us positive 50 plus or minus. This is the same thing I was talking about here, this negative sign in front of the negative 50 squared. Since you're doing negative 50 times negative 50 will also become positive. 5 times 5 is 25. Put 2 zeros in there. Minus, it was 1184
Yep.
when we did 4 times 74. Alrighty. Yes, I didn't need that guy to be that long. Over 4 times 2, which is 8. Very good. So I will need to do square root of 2500 minus 1184. And that's the guy that comes out to be 36.27671429. He is not going to be a happy number, which is okay. In application, you're not always going to end up with happy numbers, right? You can get decimal approximations, but we still need to break this down into two separate answers. So once you will do with the positive sign, once you will do with the negative sign, and just round it to 2 decimal places. No, this was just so that I can show you what that basic raw answer comes out to be. All right, so I'm going to do this once with adding the 50 plus the 36.2767, and then divide that by 2 decimal places. I wouldn't round this answer. Not the 36.2767. I wouldn't round that number. I would round once I add the 50 and divide by 8. Okay, so this will actually be an approximate. So this is coming from the 50 plus, which is coming out to be 10.78. If I did 50 minus the 36.27, divide that by 8, yeah, 1.72. And remember, this is the value for x, which is going to be that square we're going to be cutting out from our corner of the cardboard. Uh-huh. You are? And then take the square root, yeah. Is it giving you a radical answer? Yes. Okay. So this should have a T, which helps you. Oh, I did. I see. Okay.
Thank you. I didn't know. Thank you.
So when I square root 2504.
Same thing with you, right? To use this as the that's standard and decimal.
And you want each one decimal.
For these guys, yeah.
What about mine?
They should give you rounding on this, so they should say round your final answer to 1, 2 decimal places. Two nearest, okay. Yeah, my math lab is also asking me for decimal. Because you know, if you talk about a real life application, well, what does 2 square root of 3 mean? We still would have to do an approximation, right, to cut those squares out. So 2 square root of 3 would be an exact answer, but that doesn't tell us then how much corner you're cutting off. So now I have 2 answers, 10.78, which is approximately 11, and 1.72, which is approximately 2. Now let's go back to that image I had. If the width of my original cardboard is 11 inches and I cut off 10.78, is that going to be possible? No. So in practical use, you will actually end up discarding that 10.78 as your answer for x, because that number is too large and that does not give us that square. Because remember, x is this number here, how much I'm cutting off from each corner, so that, so that Imogene can make a box out of her goodies. Yeah, so this answer here will be discarded.
So would the 10.78
Uh-huh.
be the length of the?
So it's basically the two x values that is coming from that equation that we had set up.
Okay.
Right? When we did the 11 minus 2x multiplied with 14 minus 2x equals 80.
Right.
So when you set that up, because remember with quadratic equations, you will get two real number solutions, especially if your radical value comes out to be a positive number. So now you have to decide which answer makes more sense.
Would we still write it in the solution step form, or would we just leave it as that? Since they're just
No,
asking
so
for-
they're actually asking us, let me go back to the question. So they are saying what size square should be cut from each corner? So that will be a 1.72 by 1.72. You're probably gonna have to round your number because I don't think it's gonna be easy to count 1.72 inches. Sure.
Plus or minus 36, divide that by
Yeah. Okay, so you got your square root of 1316. Okay, so now to that number, add 50, and then divide that answer by 8. So this one would actually split up into 50 plus 3627 divided by 8 and 50 minus 36.27 and all those numbers after that divided by 8. Now, like I was telling you before, keep all those decimals because if you round up your answer here, then these answers will come up to be rounded. So do not round this 36.27. Keep all those digits. And since you're using your calculator, you don't even have to worry about having to type it in. The other thing you can do to keep your life easier is you can also think about this as 50 plus or minus square root of 1316 over 8, and you can type that in because we know square root of 1316 comes out to be that 36.27. So if you don't want to type that whole big decimal in, you can just type in square root of 1316 and you'll still get the 10.78 and the 1.7. Because I'm lazy, I don't like to type if I don't have to. So you can use the square root and get the same result without. Because you know the problem with typing all those decimals is if you leave one decimal out, the result will be incorrect. All right, so you're cutting off a square of 1.72 by 1.72, which actually means the remaining width is actually going to end up being the 10.78. So that's going to be part of that 80 square inches on the bottom. All right, questions on 13. Takes a while, doesn't it? You guys have an idea what you're going to do on 14? Looks like it, doesn't it? An experimental electric solar car completed a 1,000-mile race in 35 hours. For 600 miles, it traveled during daylight and averaged a speed of 20 miles per hour more than when it traveled at night, and it completed 400 miles. So 600 in day, 400 at night. It's averaging 20 miles per hour faster in the daytime than nighttime, and they want to know what was that average speed during the daytime. So why is it going faster in daytime than nighttime?
solar.
Yeah, because it's using the solar energy daytime and probably using the charged batteries at nighttime, right? That's why it's a combination of electric solar. So you're on the right path, Brandy. It is going to be a distance, rate, and time problem, but how do you set up your equation?
600 equals 35. Actually, something like that. Or would it be 20?
Well, you know, it would equal.
You're kind of on the right track.
Isn't it distance equals rate over time?
Dirt,
Would
yeah.
it be a triangle?
What do you mean?
So
Be
it would be-
this triangle. This T, D, time, distance, and plot something.
Yeah, so that would be your rate in this case, or the speed of the vehicle. I've actually never used that. That's the first time I'm seeing that. That's
What
interesting.
is it?
So this is what Brian showed me, a triangle with time on the top, distance here, and rate here. Is this something you guys have seen? I know I haven't. So how would you go about using this then, Brian?
Well, it's you need velocity divide time by speed. By distance, and you find velocity, right? And then you go to find distance.
Distance divided by time should give you velocity.
Then D should be on top. I forgot how.
Okay,
It's
so
written.
D should be on top.
Yeah.
Okay. Think about this problem. See how you're going to set it up. This is definitely the idea of D equals RT, right? What I call it, the Dort formula. And see how you need to set this up. We'll start with 14. This is the last example in this section. And then, of course, we'll be moving on to 1.6.